Hey team, welcome to week 6 of Trig, and this is actually going to be your last video and your last notes for Trig, so try to keep it together. I know you're upset, but we've made it. So we are going to do just a quick little piece of Unit 4, and that is going to be how to solve oblique triangles. And an oblique triangle is just a triangle that doesn't have a right angle. So if we don't have a right triangle, how do we solve it? Well, we have two laws that are going to help us with this. The first one is the law of sines. The law of sines says if we have a triangle with sides A, B, and C, which are opposite angles alpha, beta, and gamma. So alpha is opposite side A, beta is opposite side B, and gamma is opposite side C. The sine of angle alpha over side A is the same as the sine of angle beta over side B is also the same as the sine of angle gamma over side C. So how do we use that? There's a few helpful hints that are going to go along with this. Keep in mind that in a triangle, the longest side is always going to be across from the biggest angle. The shortest side is always going to be across from the shortest angle. Draw a picture if you're stuck. If it doesn't give you a picture, draw one out. If you know two angles, always start by finding the third angle, and always use the values that you're given and don't use anything that you've rounded. So knowing that, let's dig in. The first one we're going to look at is an angle side. So they've given me two angles and then the side opposite one of those. So if I go around, I have angle, side. So our helpful hint said if we have two angles, the first thing we're going to want to do is find that third angle. So I know they're adding up to 180. So I'm going to do 180 minus 110 minus 33 gives me 37. So I know angle beta has to be 37. So now I'm going to use law of sines. And I know I have this pair right here. 110 and 7 are going to go together. And so I say, okay, I know sine of alpha over A is also going to be sine of beta over B. So I plug in what I know. Sine of 110 over 7 is going to be sine of 37. We know beta is 37 over whatever side B is. Whenever you have a fraction equals a fraction, we do cross multiplication. So 7 times sine of 37 equals sine of 110 times B. And so to get B by itself, I would divide. So I do 7 times sine of 37 divided by sine of 110. Make sure your calculator's in degrees, and you get about 4.5 for B. So then all I have left to find is side C. So I'm going to use what I know. I'm not going to use that 4.5 because I rounded that. So just like how I found B, I'm going to start with sine of 110 over 7 because those are my given values equals sine of 33 over C because we always use the opposites together. Same thing, cross multiply. 7 times sine of 33 divided by sine of 110 gives me about 4.1 for side C. And I can kind of double check myself. I say, okay, 110's the biggest angle. Is 7 the biggest side? Yep. And then my smallest angle is 33. Is that my smallest side? Yes. So that's how that law of sines works. If we look at another one, this one's angle, side, angle. We have the side in between the two angles. So again, I still have two angles. So my first step is going to be to find that third angle. So I subtract from 180. And I know gamma is going to be 68 degrees. So now I have that matching pair. I have an angle and a side across from each other, so I can use law of sines. And so I'm going to say, okay, sine of 68 over 17 equals sine of 80 over whatever A is. Cross multiply 17 times sine of 80 divided by sine of 68. And that gives me A is about 18. I do the same thing for B. Sine of 68 over 17 equals sine of 32 over B. 17 times sine of 32, divide by sine of 68, and B is about 9.7. I can double check and say, okay, my biggest angle was 80. My biggest side was 18, so that's about right. My smallest angle is 32, and my smallest side was 9.7. So that matches up. That tells me I should be pretty good. So our next example is an angle side side. Angle side side makes the bad word. That's why it says uh-oh here. And this creates what we call the ambiguous case. So when we get the ambiguous case, that is going to create the possibility of two triangles. And so I want to show you why this happens. So we have an angle right here, we have a side, and then we have another side. So what could happen is we could get, if A is like 4.5, if I can make that happen, we could get this nice triangle right here. If A is too small, maybe I don't have a triangle at all. Or if A is big enough, I could get two different triangles. See that dark purple triangle there? And then if I swing A out, I get that bigger triangle here. And so that's why it's called the ambiguous case, because I might end up with two different triangles with an obtuse angle and an acute angle. And so that's what we have to double check for. So that's what I'm going to do here. I know A is 8.1, B is 8.3, and alpha is 72. And so my completely not drawn to scale triangle here, I know across from angle A is alpha, across from angle beta is B, and across from gamma is C. So I'm just going to do what I know. I know A and alpha match up, and I'm going to find angle beta. So I say sine of 72 over 8.1 equals sine of beta over 8.3. I cross multiply 8.3 times sine of 72 divided by 8.1 equals sine of beta. And so then we inverse sine that. So inverse sine of that tells me beta is 77 degrees. Okay, I'm feeling good. So then I can say, okay, I need to find gamma. So I subtract from 180. 180 minus 72 minus 77 tells me gamma is 31. I can use that 31 degrees to find C. So sine of 72 over 8.1 equals sine of 31 over C. 8.1 times sine of 31 divided by sine of 72 tells me C is about 4.39. I've got a nice triangle there, cool. But since it's angle side side, that spells a bad word, I have to check for a second triangle. How do I do that? Well, if beta was 77 degrees here, its other angle it could be is 180 minus that 77. That's 103. So then, if beta is 103, then what would gamma be? So it'd be 180 minus, I know that alpha is 72, minus beta of 103 would make gamma 5 degrees. So that's possible. So that's my second triangle. So then I do the same thing I did here. Sine of 72 over 8.1 equals sine of gamma 5 degrees over C. Cross multiply divide, and C would be 0.74. It'd be tiny, but it would exist. So that's my second triangle over here. My second triangle has a beta of 103, a gamma of 5, and a C of 0.74. So two possible triangles there. So let's try another one of those. This one, A is 28, B is 11, and alpha is 122. So maybe kind of like that. So I'm going to do the same thing. I say, okay, I've got that pair there. So let's find beta. So sine of 122 over 23 equals sine of beta over 11. I cross multiply, I divide, and then I inverse sine, and I get beta is 24. So then I use that to find gamma, and then I find C using my gamma, and C is 15.17. Cool. So I've got one triangle there. So then to find my second triangle, I take 180 minus 24. That's 156. So beta would be 156. But since alpha is 122, that would be impossible, right? If alpha is 122, there is no way beta can be 156. So there's no second triangle. There's just one triangle possible there. All right. One more angle side side. A is 6, B is 8, alpha is 107. Some of you will take a minute to look at that and already know something has gone terribly wrong. Okay, draw it up. If you want to set it up to find your beta, sine of 107 over 6 equals sine of beta over 8. We cross multiply, divide by 6, take the inverse sine of it, and your calculator is going to say error, because we can't have a sine more than one. It's impossible. If you come back over here and look at this, it said A is 6 and B is 8. Well, that tells me angle beta has to be bigger than angle alpha, right? But alpha is 107. And that's impossible for an angle across from that to be bigger, right? If alpha is 107 and it's across from 6, B is 8. 8's bigger than 6, so angle beta has to be bigger than angle alpha. But angle alpha is 107. And to make 180, that's impossible. So this is not a triangle. Impossible. So there's no solution there. It's a trickster. So that is how law of sines works. Sometimes we're going to have to use the law of cosines. The law of cosines is the exact same. It's just a rearrangement of the sides and angles. So a squared equals b squared plus c squared minus 2bc times cosine of alpha. And then it rearranges for the other sides and angles. So we use this for side, 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 and for side, angle, side. So if I have two sides and the angle between them, there's no pair. And there's a rando number 20 there. That's fine. It's fine. Everything's fine, guys. So I don't have any way to use law of sines because I don't have any way of pairing anything up. So if you look, I have A, beta, and C. So I'm going to use that B squared with the A, C, A, 2AC cosine beta. So I plug in what I know, and I'm going to solve that for side B. So I plug in A squared plus C squared minus 2AC cosine of beta. And then square, square, multiply those guys together. 169 plus 36 is 205. Cosine of 20, that's about 58.4, but that's what b squared equals, so we have to square up both sides, and we get about 7.6 for our b value. So now that I have that, I know one of the rules says we can't use a rounded value, but we don't really have a choice on this. There's no way to find another angle without using that 7.6. So now that I have that pair of beta and b, I'm going to find gamma. So I'm going to say, okay, sine of gamma over 6 equals sine of 20 over 7.6. Cross multiply, divide, you get gamma is about 16. And then we can subtract from 180 and say 180 minus 16 minus 20 tells me alpha is 144. So this brings us to a really important rule. When you find your first pair, always solve for the smaller angle first. Some of you are like, wait, why didn't we find alpha first up here? If we would have done that, we would have gotten this wrong. Your calculator only finds the acute version of the angle. So when we do this, it finds gamma is 16. If we would have done this for alpha, it wouldn't have given us 144. It would have given us alpha equals 54. Because your calculator only finds the acute angle. So it doesn't tell you an obtuse angle. That's why you find the small one first and subtract from 180, so that if you have an obtuse angle in your triangle, you can find it from subtracting from 180 and not doing an inverse sine. So that's your last helpful hint. We're going to do one more example. This one's side, side, side. These are the hardest ones. So side, side, side. I'm going to find the smallest angle first, right? And so, or I'm not, because I don't know. Sometimes I do stupid things, guys. So what I did is I found alpha. So that's fine. So I did 8 squared equals 6 squared plus 7 squared minus 2 times 6 times 7 cosine alpha. And do your squares, multiply 2 times 6 times 7. So here's probably the trickiest part with this. Remember your order of operations. This last part is 84 times cosine alpha. You can't do 36 plus 49 minus 84. Just add your 36 and 49 together. So get your cosine alpha by itself. So you'll divide by negative 84, and then you get cosine alpha equals 1/4, 0.25. Then you inverse cosine to get that alpha by itself, and alpha is about 75.5 degrees. Now that I have alpha and a that go together, I can use law of sines. So sine of 75.5 over 8, and I'm going to do the small one first. So that's going to be sine of beta over 6. So beta is about 46.6. Then I can either subtract from 180, or I can do law of sines to find gamma, which is about 57.9. So that's how that side works. It's a lot of work. So now we're done. That's it. Last notes, done. You are now ready for week 6 homework. That is your last homework assignment for Trig. Next week, you will have your Unit 3/Unit 4 test. I'm just going to combine them all into one. So you'll have your last test, and you will be done with Trig. So hit me up if you have any questions. Do your best, work hard, and good job.